The observable universe is a term used to describe the portion of the universe that is visible to us from Earth. This region of space is limited by the speed of light and the age of the universe, and is estimated to be approximately 93 billion light-years in diameter. However, there may be parts of the universe that are beyond the observable universe, which we are unable to see or detect using current technology. In this video, we will explore some of the theories and ideas about what might exist beyond the observable universe. Before we can discuss what lies beyond the observable universe, it is important to understand the limitations of our current knowledge. The observable universe is limited by the speed of light, which means that we can only observe objects that are within a certain distance from us. Light from objects that are further away than this distance has not had enough time to reach us yet, and so we cannot see them. This means that the observable universe is not a fixed region of space, but rather it is constantly expanding as light from more distant objects reaches us. The age of the universe also limits the observable universe. The universe is estimated to be around 13.8 billion years old, which means that we cannot see objects that are further away than 13.8 billion light-years. This is because the light from these objects has not had enough time to reach us yet. Therefore, the observable universe is a sphere with a radius of 13.8 billion light-years around us. While the observable universe is vast and contains billions of galaxies and other structures, it is thought to be only a tiny fraction of the entire universe. Scientists believe that the universe may be much larger than what we can observe, and there may be many other galaxies and structures that we are unable to see. It is thought that the universe may be infinite in size, although this is still a topic of ongoing research and debate. One theory that has been proposed to explain what may lie beyond the observable universe is the concept of a parallel universe, or multiverse. This idea suggests that there may be other universes beyond our own, which are part of a larger multiverse. These universes may have different physical laws and properties than our own, and may be completely unobservable to us. While this theory is still largely speculative, it is based on some mathematical models and the principles of quantum mechanics. Another theory suggests that there may be other dimensions beyond the three spatial dimensions: length, width, and height, and the fourth dimension of time that we are familiar with. These extra dimensions may be curled up or hidden from our view, and may play a role in the behavior of particles at the subatomic level. Some physicists have suggested that these extra dimensions may help to explain certain mysteries of the universe, such as dark matter and dark energy. The concept of dark matter and dark energy is another area of ongoing research that may shed light on what lies beyond the observable universe. These mysterious substances are thought to make up the majority of the mass and energy in the universe, yet we cannot see or detect them using current technology. Scientists are studying the behavior of galaxies and the cosmic microwave background radiation in order to learn more about the properties of dark matter and dark energy, and to try to understand what they are made of. Science is always in search of an equation for confirming a proposition, while philosophy rises above the details and reaches an empirical deduction through imagination. Theories of universe combine science and philosophy. The latter inevitably bring in the idea of God to fill in the unexplained blanks in the man's understanding of universe. Philosophy sensed that time and space had no beginning or end, which was an attribute of God. Science is struggling with this interpretation, but it has already moved to explore space and its lifespan, which is a function of time. It has not put a seal on any aspects of universe beyond the stipulation of scientists that space was still expanding. They have furnished infinity as a part of equation on the advance of both space and time. Infinity can also be envisaged as the answer to what separates beginning from the end. Seen from the presumed end, the point of origin would also be away by infinity. Infinity is science's way of conceptually measuring infiniteness. Both space and time are on a course. The question is whether this course was irreversible. However, if something has neither beginning nor an end, then theoretically these two terminals has to merge to make the process reversible. Infinity is a step towards examining universe from this angle. Infinity has received acceptance and recognition as an equation of science, but has not yet offered an explanation of reversibility of an expanding universe or a retraction in the movement of time. The uncertainty principle is another invention of science which acknowledges that in a non-static universe no positioning of any element thereof could be defined with certainty. Now, if space has to be expanding in all possible directions and time also must free itself of a linear conceptualization, then science would have to explore how their beginning and end must merge. This merger would have the effect of accommodating both infinity and uncertainty and making the cosmos a constant. Although billions of years have passed since the Big Bang, there is a cosmic limit to how far we can observe the objects that occupy our universe. The universe has been expanding all this time, but the rate of expansion has been limited and well measured. If we calculate how far a photon emitted just after the Big Bang could have traveled to the present day, we come up with the upper limit of how far we can see in any direction is 46 billion light-years. That's the size of our observable universe, which contains an estimated 2 trillion galaxies in various stages of evolutionary development. But beyond that, there ought to be much more universe beyond the limits of what we can presently see, the unobservable universe. Everywhere we look, in all directions, we see a universe that tells us the same cosmic story. But part of that story is the fact that the farther away we look, the farther we're looking back in time. The universe hasn't been around, forming stars and growing galaxies, forever. According to the Big Bang and the observations that support it, the universe had a beginning. Thanks to our best measurements of the part we can see, we're finally figuring out what lies beyond, and how much of it we'll someday be able to perceive and explore. What do you think about the infinity of the universe or the topic we discussed? And if you enjoyed the video, then hit the like button. If you haven't subscribed to our channel for more informative videos, subscribe to it. Thanks for watching.